In this video, I'm going to teach you how to work with algebraic equations that contain parentheses. That word I have written in big, bold letters in pink right here. So when you hear the word parentheses, you probably call to mind grouping symbols that look something like this that I'm drawing. And they tend to include a combination of some sort of a number, perhaps 4, and a symbol in the middle, perhaps an addition sign, and maybe another variable like an x. It's also often the case that directly in front of these parentheses or grouping symbols, you may come across a number such as 3. Right here, we see the 3 is placed directly against our first parenthesis. This indicates that, in fact, multiplication is taking place. So this entire expression contained inside of my parentheses is being multiplied 3 times. Down below here, I have prepared an algebraic equation that contains parentheses on the left side of the equation and the right side of the equation. As a general rule of thumb, whenever you come across parentheses in an algebraic equation, you always want to simplify the equation in such a way that you were able to clear the equation of parentheses. In most cases, that will involve utilizing the distributive property. So on the left side of the equation, I'm going to draw arrows from my 9 over to my t and from the 9 over to the 2. This is meant to indicate to you that I'm intending to distribute my 9 to the t, and I'm also going to distribute this 9 to the 2. I can rewrite this left-hand side of the equation as 9 times t plus 9 times, and I'm being very deliberate about my color coding here to really help you understand that, to sort of exemplify the utilization of the distributive property here. So the 9 that was written up here once now appears 2 times down here. In a similar way, I will do the same to the right side of the equation. I'm going to distribute the 3 that is in front of the parentheses to the t and to the 2. It's worthy of mention that in this instance, there's a subtraction symbol in the middle of my parentheses, whereas on the left-hand side, I had an addition symbol. So when I distribute my 3, I am left with 3 times, bear with me while I change colors, t minus 3 times 2. Once I've reached this point, I now need to go ahead and simplify the expression, or the two expressions, but the equation as a unit further. 9 times t, I can't really simplify this term, but I can write it simply as 9. No, I shouldn't write it like that. It looks more like a Q. I can rewrite that as 9t, which we all know we understand to mean 9 times the value of t, whatever that value may be. I'm going to draw a little dot there just to emphasize that multiplication is happening. And then I will add this to 9 times 2. I can simplify that to 18, and this is equal to 3t minus 6. From here, we now have an equation that looks similar to an equation I shared with you in an earlier video, one that dealt with the concept of equations that contain variables on both sides of the equation. So having already watched that video, we all know that we want to collect like terms, or in this instance, our variable terms, on one side of the equation. I tend to prefer to collect my variable terms on the side of the equation where the quantity is larger. I do this to avoid introducing negative numbers when I don't need to. If I were to bring my 9t over to the right side of the equation, I worry that I would create a negative value. Whereas if I subtract 3t from both sides of the equation, bring my 3t to the left, I believe my variable factor will continue to be positive, and therefore the equation should be simpler for me to work with. So I'm going to do just that. I'm going to subtract 3t from both sides of the equation. And I'm actually going to bring down my equal sign just so we all really understand what's happening. Here we have 3t minus 3t. That becomes 0. And we are left with 0 minus 6 equals. And then over here on the left we have 9t minus 3t. That becomes 6t plus 18. From there, we can rewrite the entire equation just in a slightly simpler way. 6t plus 18 equals negative 6. Again, remembering that the goal is always to isolate my variable. The next move that I would like to do is to somehow remove this 18 from my left side of the equation. I can achieve that if I perform the opposite operation of addition, that being subtraction, and subtract 18 from both sides of the equation. When I do that, I have 18 minus 18, that equals 0. So I'm going to draw my little equation bar, so like that. As I was saying, 18 minus 18, that equals 0. And then in front of that we have a 6t, and that's equal to, now we have, I'm going to write out the entire equation just to ensure that we understand exactly how to work with the numbers negative 6 minus 18. So I'm going to write the full equation, or the full operation out as negative 6 minus 18. So 6t equals negative 6 minus 18. In this particular instance, I know that my answer over here on the left side, I know that it will be a negative number because if I were to sketch a quick little number line, I'm starting at negative 6 and I'm subtracting, I'm taking away 18. So this indicates to me that I'm going to move further into the negative region. Ultimately, I will land at negative 24. So I'm going to erase this little arrow that I drew and show you, sorry, I'm just looking for my eraser. Oh, I don't know how that happened. Here, I will just move down and show right here. Negative 6 minus 18 equals, put this in parentheses, negative 24. So if I were on the number line and I'm starting at negative 6 over here, I'm going to hop, as I say, to the left into the negative region. I'm going to hop in this direction 18 spots, and I'm moving 18 spots because I'm taking away 18. And if I were to do so, I would ultimately land at negative 24. So moving along, I can rewrite my equation as 6t equals negative 24. From here, again, remembering that the goal is always to isolate the variable, I know that on the left-hand side of the equation, I can see multiplication, 6 times t. So I'm going to perform the opposite operation, that is, divide both sides of the equation by 6. 6t, 6 times, or t multiplied by 6 divided by 6 will ultimately yield t. And we can say that t equals negative 24 divided by 6. And then I can simplify that one step further and say t equals 4, and negative 4 in fact. And then I will put a box around my answer. So let's take a minute to quickly review how exactly we found the solution to this particular algebraic equation. So we first began off by just introducing the concept of equations that contain parentheses, and I drew for you a little sample of a common parenthesis expression that you may come across. And then from there, we worked with the equation 9, open parenthesis, t plus 2 equals 3, open parentheses, t minus 2. We then utilized the distributive property, and through doing that, we were able to clear away our parenthesis symbols, and we were left with the equation that read 9t plus 18 equals 3t minus 6. At this point, we were now working with an equation that contained variables on both sides of the equation, a topic that we recently covered. I decided that it would be a smart idea to move the 3t from the right side of the equation over to the left. Ultimately, I rewrote my equation as 6t plus 18 equals negative 6, which we can see down here. And then I subtracted 18 from both sides of the equation to remove this 18 from the left side of the equation, helping me to isolate the variable. And then once we completed that operation, we were left with 6t equals negative 24. From there, I decided to divide both sides of the equation by 6 to remove the multiplication of 6 that is taking place in front of my t. I often refer to this number as the coefficient, and ultimately this led me to my answer, which is that t equals negative 4. So if you have any questions about this video, take a minute to record them in your math journal, or if you would prefer, come to class ready with questions to ask me in person.